Next up is Dr. Tempest van Schaik, Senior Machine Learning Engineer Healthcare at Microsoft. We're excited to hear from her about her responsible AI journey and as she shares some of her practical RAI tools and techniques that can be used throughout the AI lifecycle, special RAI considerations for healthcare, and the experts that she looks to as she continues in her journey. Take it away, Tempest.
Hi, my name is Tempest van Schaik, and I'm going to be talking about responsible AI in health, from principles to practice. I am a senior machine learning engineer at Microsoft in commercial software engineering, CSE, and we work with Microsoft's big healthcare customers building real-world machine learning projects. So a little agenda for today and what I'm going to cover. So I'll start with the historical journey of responsible AI, then look at some responsible AI lessons coming from biomedical research, review some of the responsible AI ethical questions that we ask in my team, and then look at some of the responsible AI tools. So to start with the historical journey of responsible AI, whenever there's been new technology developed, there's usually that is followed by safety and responsibility considerations. For example, the car, when that was initially developed, there was the first car fatality. And following that, there were a series of safety measures that were introduced in cars and streets, like windshields and seatbelts and even the driver's test. So looking back, it seems obvious that a car should have these features, but at the time it was not obvious, and these were implemented to address safety and responsibility. The field of AI is in a similar situation. There were some incredible breakthroughs a couple of years ago, and now we're starting to think more and more about responsibility and safety. So what I've observed in the field is the question shifting from can we do it to should we do it? So a couple of years ago, there was a lot of excitement about whether we could build machine learning that could recognize faces, because that's a really exciting engineering breakthrough. And now the discussion is really around should we be doing that when we look at the consequences of that kind of technology and what impact that has on people. So now I'll talk a little bit about my personal interest in responsible AI and my journey. And it started with lessons from biomedical research. So I find it interesting that some of the concerns with AI today are familiar from biomedical research. So for example, one of the most important medical research ethics papers to come out was the Belmont Report in 1979. And this addressed some very, very serious ethical mistakes that had been made in biomedical research. So 1979 shows that biomedical research has quite a head start on AI, a couple of decades there, because these mistakes have been made. So some of the standards from biomedical research that are now considered part of responsible AI are, first of all, dataset transparency. So when you publish a paper in medical research, you have to be very transparent about who was in your dataset, what research participants were there, what age were they, where were they from, what race were they, what was the level of education, and so on. You're really transparent about that, which is something that we're seeing in responsible AI too. Also the concept of informed consent, group harm and individual harm, and privacy are all concepts that you find in both, and I find that parallel quite interesting. Being primed by my own background in biomedical research, I've been looking at engineering problems through this lens in my career. Some time ago, I had an AI project come to me, and I had ethical concerns with this project. It just raised some red flags for me for the first time in my career. And I was supported by leadership to ask these sort of questions like, should we do it? Not can we do it, but should we do it? And going through those questions and finding what tools I could use to address concerns has prepared me for recognizing and addressing responsible AI issues on future projects. So we started a responsible AI review board in CSE, in commercial software engineering, because we work on really diverse customer AI projects. So we work in different industries. I work in healthcare, and we work with lots of different types of data. So we work on image data and computer vision. We work on text data and NLP and structured data and regression. So we really see a variety of AI projects, and therefore we also see a variety of complex, diverse AI ethical issues, which we have to work through. So we created this responsible AI review board as a sounding board for these conversations around responsible AI. And we provide responsible AI recommendations for every project that comes through our team. So whether it is a project where we are building a bespoke machine learning model from scratch, or we are taking an existing model and putting it into production, either way, all machine learning projects have to go through the ethical review. And so I'm going to share some of the questions that we ask during the ethical review in case they are helpful for you to ask. So one of the first questions we ask is, well, we highlight that AI is not magic. So we ask, is this problem actually solvable with AI? Or is this a social problem which should have a non-technical solution? If it needs a technical solution, can it actually be solved in a simpler way, or do we have to use AI? So sometimes we could actually solve the problem with a SQL query instead of a machine learning model, because if we do build a machine learning model, there are responsibilities that come with that. So we always ask if we really need to use AI. If we do, we ask, who are the stakeholders in this project? So we think about who the AI impacts, and especially if there are any vulnerable groups affected. So we think about all the people that could be impacted. Vulnerable groups could be children or immigrant groups, and the stakeholders could be everyone from national security to customers and end users, and we think about all of these stakeholders. Then we think about the possible benefits and harms to each stakeholder. So we list out all the benefits and harms to all the stakeholders, and we do this exhaustive list, which really helps us weigh up the pros and cons and their benefits and harms. We ask if the data used in training or scoring contains PII, personally identifiable information, and if this is really necessary. Do we really need things like people's names to train a model? And if we do, then we really have to take into account privacy and security considerations. We ask, does this model impact consequential decisions, like blocking people from getting jobs or loans or healthcare? Any of these are sensitive use cases that would need special consideration. And in many of these use cases, the model needs to be explainable. So we ask, do we need an especially trustworthy and transparent algorithm in this case? Because some machine learning models are more transparent and interpretable than others. We also ask how the technology could be misused and what could go wrong. And we call this Black Mirror brainstorming. And it's named after the UK TV series where they explore how technology can be misused. We ask, does the model treat different users fairly? So it might be a very accurate model overall, but there might be one user group that it's performing very badly for. We ask, how does the training data compare to production data? So is this training data a good representation of how it will be used in production? We ask, what is the environmental impact of the solution? So if each time we need to train a language model, it uses as much energy as a city, then that is a serious consideration we need to take. And finally, how can we address these concerns that arise, and how can we mitigate risk? So it could be that we don't do this project, or we reformulate the problem, changing the focus slightly, or we might look at some different tools that will help address some of the issues that have been raised. And I'm going to talk a bit about some of the tools that we use. But there are some special responsible AI considerations for healthcare in particular. One of the most obvious is privacy. When we are dealing with people's medical data, it's extremely important to maintain and respect their privacy. And hand in hand with that goes the security around handling that data. So when we're working with real data sets, we need to do potentially a lot of training on institutional review boards and ethics and HIPAA and any kind of regulatory training. So that's really important for anyone working in healthcare. There's also an interesting balance between open versus closed science. So on one hand, we want to keep data private and secure. On the other hand, if we open up access to data, then potentially more researchers could use it and do medical research that benefits a broader population. So there is this push and pull for open and closed science. Another issue is unequal access to healthcare. So wealthy people in wealthy countries have better access to healthcare, and that's something that we need to always consider. What I found particularly interesting in the United States is how bias can be introduced through the cost of care. So even if we look at how people pay for their treatment, whether it's through Medicaid or Medicare or private insurance, that can tell us a lot about the population that's being affected by this algorithm. So we have to be really careful about bias that's introduced in any cost measures of health in the USA. Which I'm going to elaborate on. And also, race and sex are often loaded with bias in machine learning. These can also be important disease predictors, as we saw with COVID. So we have to be really careful about, we can't necessarily just remove these to remove the bias. We may actually need them. So I'm going to share a paper which I found interesting, which touches on these last 2 points. And this is a paper by Obermeyer et al., and it's called Dissecting Racial Bias in an Algorithm Used to Manage the Health of Populations. So these authors investigated an algorithm that is used widely across the US by millions of people. And this algorithm does not use race as a feature. So it's completely has no access to the race of patients. But it was still very racially biased, which is the interesting thing. So they used the cost of care of Black and not Black patients to predict who was the sickest and therefore who needed extra treatment. But the cost of care for Black and non-Black patients is very different. Black patients have much less spent on them than non-Black patients. So if you use that to predict who's the sickest, you get very, very biased results. So I think this is an interesting example of how merely excluding feature like sex or race does not make it necessarily less biased. And in fact, in my experience, I found it's better to include race and sex because then if the model is biased, you can track it and you can quantify the bias rather than trying to exclude it. And I'll show another example on how I've looked at this problem. So now I'll show 3 different tools coming from Microsoft that are open source tools addressing some issues in responsible AI. The first tool helps answer the question, is there a good representation of all users in my data? And this tool is called Datasheets for Data Sets. And it's a framework. It's inspired by electronics engineering. So I've got an example of a data sheet from electronics engineering shown here. In electronics engineering, when you buy an electrical component like a microcontroller, you get a data sheet with it. And the data sheet tells you all about the microcontroller, its operating range, how to connect it, and everything you need to know. So this framework is suggesting that every time you release a data set, you should release a data sheet to accompany it, explaining exactly who are the people in this data set, how is the data collected, and the limitations of the data set. A language model trained on Twitter conversations is not appropriate for a medical literature project because the data sets are very different. So this framework promotes transparency in data sets. The next tool asks the question, does the model treat different users fairly? And a tool for this is called FairLearn. It was developed by Microsoft Research, and it is a open source Python package. And this is how I've used it. So I was looking at the accuracy of a medical model, and you can see that the accuracy at the top there is area under ROC curve, and that was an accuracy of 0.92. which sounds quite good. But then using FairLearn, you can break it down into lots of different metrics, including looking at the accuracy per group. So we can look at the accuracy for female and non-female patients, and also look at the accuracy by different racial groups. And there's a lot of interesting metrics there to help you keep track of whether the model is performing equally well for different groups. So that one is called FairLearn. And then lastly, I wanted to show a tool that addresses the question of, does the model need to be explainable? So especially in healthcare, if we are predicting who should get medical treatment or not, it's very important, or some kind of medical intervention, it's very important that the model is explainable and interpretable, because some models just make a prediction and we have no idea why they've made that prediction, whereas others are much more explainable. And that's really important for doctors to be able to have faith in the model. So InterpretML is another MSR, Microsoft Research, open source Python tool. And it's a suite of visualizations, but it's also the explainable boosting machine model, which offers high accuracy and high explainability. So here's an example of a model that is predicting, this is from the adult income data set. So it's a model predicting whether someone earns more or less than $50,000 a year. And we can see that these are the different features it uses to predict that, like gender, race, the native country is, and so on. And we can see that in orange, these are the features that are for predicting over $50,000. So we look at capital gains, hours per week, education years, and in blue are the features that are against that prediction. So their occupation and marital status and so on. So this model is explainable because you can see the weighting that it's put on each different feature to arrive at that conclusion. And I wanted to end with some resources. I'm not an expert in responsible AI. I'm a practitioner, and I looked at these experts to try and understand the best practices in responsible AI. So I would recommend reading and following people like Kathy O'Neill, Hannah Wallach, Timnit Gebru, Rachel Thomas, Deborah Raji, Kate Crawford, Arvind Narayanan. And if you are new to responsible AI, then this Netflix documentary called Coded Bias is a really nice primer. I'm also looking forward to reading these two books by Kate Crawford, Atlas of AI, and Redesigning AI, which is a special edition of the Boston Review, edited by Darren Ashimoglu, with essays from a lot of these authors. Also, here is a link to the Obermeyer racial bias article I mentioned, and a link to Microsoft's responsible AI tools. And another resource is in commercial software engineering, we have a GitHub repo where we share our best practices for engineering. And I've just added a page to that sharing our responsible AI resources and a list of some of those questions that we ask ourselves, which could be helpful. And that's it. Lastly, I just wanted to highlight that our team, Commercial Software Engineering, is hiring. So this is the Applied ML team where I work. We're hiring currently in the United States and also in Australia. So check out those links if you're interested. And that's it. Thank you very much. Thanks to Data Points and Grid Dynamics. And you can find me easily on Twitter and LinkedIn. Thank you.
Great. Thank you so much, Dr. Van Schaik. We do have a couple of questions from the audience, so I'd like to go ahead and jump right in. First one is, how do you balance when you have customers wanting to pursue an ML model and the review board considers it not the right fit?
Thank you. That's a great question. Actually, what I've found is that customers are really excited and curious about the responsible AI process. So what we do is we actually share the responsible AI process with the customer team. We make these documents where we're exploring the issues, and we share that with the customer so that there's transparency about the process. And we find it's really well received. Customers are excited to learn about the process, and generally they want to learn best practices from CSE. which is the engineering practices, but also responsible AI practices, and kind of want to, look at the industry standards and learn the best way of doing things. They don't want to build models that are going to cause harm or, release something that will make their company or their brand look bad. So generally, people are really excited to see the process. And we actually leave that documentation with our customers so that they can own it afterwards. They can evolve the documentation as the project progresses through the different lifecycle stages. So when they're still doing development, and then through A/B testing, and when it actually gets used with loads of end users and then maintained, these are all good opportunities to keep asking responsible AI questions and evolving your thinking as new information comes through. And we can also help customers reframe the problem. They might say, initially we thought this would be a good idea. Actually, after consideration, we think reframing it would be better, and they tend to be very open to that too.
Wonderful, thank you. The next question we have from the audience is, were there projects you worked on during the COVID pandemic that had RAI challenges?
Interesting. So we saw quite a variety of COVID projects. It was interesting to see how they evolved as the pandemic evolved. So initially, a lot of the projects that I saw were around modeling the spread of COVID. I would say part of responsible AI on any project, any healthcare project in particular, is to work with domain experts and to make sure that if you are working with the spread of disease, that you have some epidemiologist or some kind of healthcare professional working with you so that you're not making inappropriate assumptions. So we always work with relevant domain experts. That's really important. So in the beginning, there were modeling projects. I think later I saw sort of a trend towards the distribution of PPE and masks and making equitable distribution possible with AI. So there you need to work with, logistics experts. And then in the later parts of the pandemic, we saw a lot of modeling around returning to work safely and how best to do that, in which case, you need to work with the experts in those fields. So having those experts are really important.
Awesome. Well, thank you so much. It looks like that's about all the time we have for audience questions today. If you would like to connect with Dr. Schaik further, her LinkedIn and email are here in the console. You can also download our presentation in the resources section. And here in the next few minutes, don't forget to jump over to our final presentation of the day. Miriam Friedel, Director of Software Engineering at Center for Machine Learning at Capital One, will be talking about standardizing the model development process. We'll see you there. Thank you.
Thank you. Bye-bye.